Okay, so I'm excited for this one. Here in this new episode of Peeling Bitcoin, I have Bruce with me. He is the creator of sCrypt, Lambit, and also the founder of Opcat Layer. But in this episode, we're going to be talking all things script and the work that he's been doing for script for the past few years, actually. So thanks again for joining us on this episode, Bruce. To kick it right off, what made you so interested in Bitcoin script?
Yeah, I'm from the a tech background, so I've been working programming. I don't know, like for the past 20 years maybe. So starting with C, Java, Python, TypeScript, whatever you know. So and then I was after got my PhD in computer science, I was working at Facebook as a research scientist. Back then was still called Facebook, nowadays it's Meta. I was working there on the infra, but then that was around 2016, actually, 10 years ago. And a lot, in the valleys, like after work, everybody's tinkering with some new technology. So I was doing, back then it was called blockchain and later Web3 and crypto, whatever. And I just found it fascinating because it's for the first time, it's the first technology I know. You just run some code in a garage and maybe put some hardware and then you're pretty much printing money. So I'm like a curious guy, so I want to understand how does this work? And then just spending more and more time into so-called crypto. And then in 2017, I decided to leave and, leave Facebook and then start my own Web3 startups. So I've been into the space almost 10 years. When I first got into crypto, like everybody else, I was working on Ethereum because that's like, it's like the go-to platform if you want to develop anything. And then in 2017, there's a few big events. I think one is the Crypto Kitty. I don't know if people remember, that's like the first popular, I would say, NFT type of projects. And then I think it's a few thousand people play it. And then the whole blockchain was congested. And it's like I'm texting you or I'm browsing YouTube videos and then I'm clogging the whole internet. No other apps can work. I think to me, that's like, to be honest, that's kind of stupid if you want to call yourself work computer and then you cannot handle like a few thousand people in one app. So then I decided to explore what's going to scale. And it happens that was a big block versus small block in Bitcoin space. So I was just curious, why do people still have on this like a boomer dinosaur technology, even we already have Ethereum or EOS or, Hashgraph or whatever so-called blockchain 7.0 or 2.0. So I was, just did a very deep dive into the origin of Bitcoin, why Satoshi did it. And it was during that 2 months of deep dive, I found out, hey, Bitcoin was designed to do everything. The guys, he put, so-called a virtual machine in the first version of Bitcoin. It's not an afterthought. We just haven't explored its potential. I think then I'm curious to say why people haven't developed on this. And then I found out, hey, Bitcoin script, like opcodes, dual stacks, and all the Turing completeness. But then there was no, so-called, you are DevRel, so there's no developer tuning. It's all like a raw metal. It's like programming assembly. So, but all the ingredients was there, but you just need to build a higher abstraction so people can start building it. So that's pretty much what I've been doing for almost a decade now.
That's a really good point. I mean, for Bitcoin, for developers that want to either work on Bitcoin Core or just develop Bitcoin apps or Bitcoin wallets, like the dev tooling is still it's a lot more mature right now, but I would say it's still very scattered, like especially for script itself. So script is kind of like it is the smart contract language for locking and unlocking UTXOs for Bitcoin. And I think many people would still say the dev tooling for just working with script is still very nascent and still very scattered. What would you say is some of the misconceptions about, in general, working with script?
I think the biggest misconception is you should not work directly with script. The analogy would be you're an Ethereum developer and then you work with big Ethereum virtual machine, bytecode or opcodes. So they also have a virtual machine. They also have a lot of opcodes. I don't know, maybe 200-ish. So you can add things. I think you can also like multiply things. You can call functions, but no developer I know of work on Ethereum program in EVM, bytecode, opcodes. They all work with something like a higher level. For example, the most popular Solidity, but you also have Viper and a bunch of other alternatives. Also, it is like you are developing web apps, in web app, also you have the, virtual machine. Also, you have instruction sets called opcodes. Even when you are programming JavaScript, for example, maybe you are using like a V8 engine, right? But nobody I know of program these apps using the bare metal, the opcodes, which is like assembly, right? You all always work with JavaScript or whatnot. You never should touch, the bytecode unless you are working on the compiler or you are doing some like a very low level optimization. You should never touch that. You shouldn't even know it exists. That's how, it should work. But unfortunately for Bitcoin, for various reasons, a lot of people, they're still working with the raw metal. It's like you're still programming assembly in 2026 with all the AI toolings, it should not be the way to go.
That makes sense. It's a good argument too. And I think that's a good segue into, so you developed sCrypt, and sCrypt is meant to be an abstraction language for script itself. So tell me a little bit about the design philosophy at sCrypt, and I guess how the adoption has been when you first started it a few years ago.
Yes. So, sCrypt, as you said, it is trying to solve exactly the problem. Because when I first find out, hey, Bitcoin to do all this so-called, today we call it smart contracts, and Satoshi called them like a different transaction types. But basically is meaning Bitcoin is not only for simple transfer from Alice to Bob, it's just meant to be programmable. But then the obvious obstacle, you need something like a higher level language. There are a few attempts before, but it's all very, I would say it's still very, very difficult to work with. For example, there's a language called Ivy, some other languages. It's all still very esoteric. It's nothing like, JavaScript or Solidity. So that's why I decided to create sCrypt. Think about it's just Solidity or JavaScript for Bitcoin script. It's a high level language, any developer, should be comfortable with. All the syntax, all the abstractions, should be very straightforward. And then it gets compiled down to Bitcoin script. It's not like you are just inscribing some code in like ordinals or whatnot, and then interpret it in another virtual machine. You are running the native Bitcoin. I call it Bitcoin virtual machine. I maybe maybe that's a term I coined. You can find out if there's anyone that coined later, even earlier, but I call it Bitcoin virtual machine. So that's how it came to be. And the whole philosophy is make it as simple as possible for any developer, to come and build with, Bitcoin smart contracts. So that the syntax is very similar to, for example, TypeScript, or because that's pretty much the most popular language out there. I didn't choose JavaScript because it's untyped, and you want to, for anything that deals with real money, especially your Bitcoin, you want to be as secure as possible, because any mistake, it's not like you're building a website and maybe it crashes and maybe you refresh and then comes back. It's not end of world, but you have make some even tiny mistake when you lock up your Bitcoin. Later on, you cannot retrieve it. That's like catastrophe, disaster. And so design first, it has to be very easy and friendly to developers. Second, it has to be, I would say that the number one priority is get it as secure as possible, meaning at the design level, you want to minimize the number of attack surfaces and eliminate a lot of problems that at the syntax level, it can never happen. For example, the most popular bug in Ethereum is so-called re-entrance. For example, the most famous or infamous DAO hack, right? It calls it Ethereum split, Ethereum and Ethereum Classic. It was because the re-entrance. So we designed, for example, sCrypt, everything, there's no re-entrance. You can just call a function, but you never can come back and call back. So you can never have that problem. So for that design, it has been working. I think I first started working with it at 2019, and at this, so I would say it's.
If I can pause you right there, actually. So at the time when you first started creating sCrypt, there were other attempts at some kind of abstraction language for script, correct? And then
Yes.
I'm assuming you've tried those, and like, what were the issues that you saw with those other attempts?
Yeah, why, as I said, it's not. I mean, it's easier than script, but I wouldn't call it the developer friendly at all. It's very, it's almost this developer that they're trying to show they're smart. So they come with something very, I would say, too overly complex. So for example, you got a language called Ivy. I mean, it's not raw metal, but it's still very close. It's nothing compared to JavaScript or Python or anything or, Rust. It's very, it's something between like a low level language called a script and then higher level language. It's something very, they come up with that's nothing close to what the developers already are used to. And the tool is almost non-existent. So they may have some like a CLI, but that's pretty much it. No documentation, no, websites you can go to, you just click and see what the script gets compiled to. It's not easy to deploy. It's not easy to call. There's no library. Basically, it's almost like a weekend project. It's nothing, nothing close to Solidity, I would say. So that's why I say, hey, instead of just, get these people to improve it, which is out of my control, I would take over and then make my version of what, developers should, be comfortable with and familiar with.
So if like for any beginning developers out there, I mean, like one can make the argument that most locking and unlocking transaction types only consists of like a few different opcodes, right? It's actually in very maybe rare cases where you're actually writing and scripting complex locking scripts. So then I'm curious, like what were some of the complex scripts that you were writing or interested in writing that really that you felt was factor in developing sCrypt as well? Were there certain types of like really, yeah.
Yes, it's like asking, Solidity developer, hey, what kind of smart contract that's useful outside of the normal Ether transfer? I would say, one big reason is exactly because it's very difficult to work with script. So that's why you don't see many use cases. Once you have get the entry, the barrier as low as possible, and tons of developers can work with, and then you can see you're basically giving the freedom to the developers, because the analogy I would use, even, Steve Jobs, he was a genius. He created iPhone, but I don't believe he could see what are the killer apps for iPhone when he first released it, right? I don't think he knows Instagram or Google Maps or Angry Birds. He just give it it's like asking him, hey, why, what are the use cases for iPhone when you first released it? I think people making calls and then maybe play a few, arcade games, but that's about it. Same with the Bitcoin, because exactly when it first came out and it's very difficult to work with, it's like when you work with iPhone at the beginning, there's no app store. You probably don't have good SDKs or documentation or even language support. So that's why it's very, you don't see many apps, but that doesn't mean it's not going to have many use cases. For example, for sCrypt, one of the, I would say, most popular stuff is, this thing called zero knowledge proof. Right? Because if you want to hand program a zero knowledge proof, I mean, people did it later, maybe after 5-6 years in BitVM world. But that's like, you have to know exactly how script work, and then you are drawing out the, the stack diagram as you program. If you tweak anything, you have to restart it pretty much again. So it's maybe a handful of people can program it. But with sCrypt, yes, as long as you know the algorithm, you can pretty much, anybody can program it. So once you have the primitive, you can create all kinds of things. For example, you can create, games that has hidden state, right? Like a poker, or another one called Battleship, or you can even have a tornado cash type of so-called, mixers, or you could have, anonymous transfers. You could have blind transfers. So that's just one of the primitives. Another primitive I would say is a lot of people, they want to make the self-custodial Bitcoin more secure, right? For example, you can have vault. All this, you can basically, the biggest unlock, I would say, for now, these days, if you want to have any kind of advanced, functionality in Bitcoin, you pretty much, I hate to say it, you have to go to talk to the core developers, you have to, lobby Michael Saylor or whatnot. Imagine this is what happens in Ethereum. You could never explode, right? Yeah. You have to, any functionality you want to add, new one, you have to go to talk to Vitalik or Ethereum Foundation. That's never going to happen. So I think the biggest unlock is you just give them freedom, they won't, and make it easier. The developer, they are going to come up with all kinds of ideas. For example, I just talk a few, right? For example, zero knowledge or vault or, games or even doing tokens and AMMs or, Launchpad. That's what I've seen people build and layer one tokens like the equivalent of ERC20, ERC721. So once you have sCrypt, which is like Solidity, and then you have ERC20, like we call it CAT20, and then the ERC721 equivalent CAT71. Once you have these three, it's like on Ethereum, you can program anything you want. So that's just the biggest unlock.
Gotcha. So now before we transition into opcat layer and Lambit, I want to stick with sCrypt and I guess, the motivations behind creating sCrypt. So, and it sounds like there's almost like a twofold reason for creating sCrypt. One is to just make writing in script easier and simpler for developers. And two also is your belief that there should be more programmability on Bitcoin. Like you said before, there should be more applications on Bitcoin, directly on Bitcoin. Now, when you were, for sCrypt, was sCrypt basically ready to use for any mainnet enabled opcodes, or what was it also covering disabled opcodes?
So sCrypt, the a little bit history. So I was joined the Bitcoin ecosystem. That was only BTC, but then in 2017 it forked right into BTC and Bitcoin Cash, and Bitcoin Cash re-enabled pretty much all the opcodes, disabled opcodes. So you probably know the history. So originally there was about 100-ish opcodes in the first version when Satoshi released it. Later on, because he thought maybe some of them has some bugs, and then he disabled, not delete. It's still in the you go to GitHub, you go to Bitcoin repository, it's still there. It's like commented out. It's like disabled. So that's about 15-ish. One of the most famous is opcat, but that's like multiplication, bit shift, a bunch of others, and he wants to test it out and make sure, maybe even audit and have people review it and then re-enable. But then he left, and then people kind of like forget about all the whole thing till ordinals, a bunch of others, and then people find out, oh, you have the opcat and a bunch of others. Back to your question. Yes, it works on Bitcoin mainnet today. That's a fork of sCrypt. So we make it work with BTC. So of course the limitation is you can only use the existing enabled opcodes, like maybe 85-ish or maybe 90. So when you write the programs, you're not allowed to use it. For example, cat, you cannot concatenate. So that's the limitation. So we work with all the Bitcoin, forks, maybe BTC, BSV, and Fractal, and today, of course, opcat layer.
Gotcha. Okay. That's
it works,
right.
but it's very limited because of the disabled opcodes.
Gotcha. And then one last question before we move into opcat layer. What was the general reception like around sCrypt from other Bitcoin developers? Did anyone notable come out and kind of praise it or kind of criticize it?
Yeah, I have yet to find out who criticized it because it's just a tool. If you don't like it, just don't use it. I think nobody is forcing. Yeah, there's a bunch of people. I would say, for example, the guys, pretty much created BitVM. One guy called Super Testnet. Yeah, he was like, oh, okay, this is cool. I didn't know this exists. So he's going to try it out. And Jeremy Rubin, I think last year I was in Hong Kong. I'm almost sure it was Bitcoin Asia. So we were at the dinner. I think we were at 2 dinners together. I was showing him, hey, this is sCrypt. You don't have to write, staple or whatnot. You can this is much easier. This is just TypeScript. So he said, this is cool. What else? Yeah, others is just like probably not that, let's say, famous. There are like a few thousand people in the world, that maybe 10,000. I don't know the exact number. It's very hard to track, but they're all over the world. They have used this, and I've yet to receive some, let's say, negative feedback. So I think it's pretty good. And I'm proud to say there's no sCrypt bug that has caused any asset loss in the history. So it's very, very robust. Yeah.
That's awesome. Yeah. For me, the reason why I came across you on Twitter was because of sCrypt, and I've always thought that was a really interesting tool. So let's transition into Lambit now and opcat.
Can I quickly add something?
Yep, sure.
Yeah, so sCrypt pretty much has two versions. I would call it the legacy sCrypt, which is its own independent language. Like it's similar to JavaScript, but it's not JavaScript. But then the second version, we pretty much upgraded to 100% JavaScript. I mean, like in TypeScript. So the current version is 100% TypeScript. You don't, the syntax, everything, the tooling, you can use NPM, you can use your favorite IDE like VS Code. So what we found out is in one point, in the legacy version is good, but it's like a very still niche because nobody wants to learn new language. It's very difficult in today's world. How many new language gets adopted by the mainstream in the past, I don't know, 10 years or 20 years? Maybe Rust, maybe, I don't know. But it's very, very difficult. Or Swift. But it's very, people still program in C, right? So it's very, the network effect is crazy in the language world. So that's why we decided to take a lot of effort to upgrade it to TypeScript, which is any Web2 developer, they can come up and then they can program in it. So that's just some upgrade we have done. And we found out after that, it's like 100 times easier or 1,000 times easier for people to develop. Yeah.
For sure. And for any developers that are interested in checking that out, I'll share links in the video description. And then, so going on to Opcat Layer and Lambit. So Opcat Layer is, I guess you could say, the most recent work that you've been doing. It is not a Bitcoin L2, but it is more of like it's, I mean, you can correct me in a second, but it's kind of like a Bitcoin fork that is supporting those 15 disabled opcodes. And then in order for anyone to write contracts on the Opcat layer, which is Opcat layer is aptly named after the Opcat opcode, which you are very supportive of. Opcat layer, in order to write contracts on the Opcat layer, you would write in the language called Lambit. And now it seems like Lambit is similar to sCrypt, but I'll have you kind of explain the differences between those two different languages.
Yeah. So on Opcat layer, it's basically, as what you said, is basically like a Bitcoin, but with all the disabled opcodes enabled. And also we remove all the artificial, let's say, limits, like 1 megabyte blocks or 250 bytes of, script element and a bunch of anything that's artificially not at the protocol level. We just make it uncapped. So that's basically the idea. Also, we share the same asset with Bitcoin. Basically, there's no new token. You just bring your Bitcoin and then you can use all the apps. That's the gas. And also we are doing merge mining. So you share the same proof of work with the Bitcoin mainnet. So I was saying in all the so-called Bitcoin layers, as close to Bitcoin as the most close resembling Bitcoin, in my opinion. Okay. So back to the Lambit. Almost 10 years ago, when I first started working with Bitcoin script and maybe getting started with sCrypt, I also want to create something, super secure that you can prove is correct. So the reason why we upgrade, we basically switch. You can also program basically Opcat layer using sCrypt also, but I feel it's time for another upgrade. Because in the age of AI, I just don't feel sCrypt is that secure. It's like Solidity. You have programmed Solidity for the past 10 years, and then all of a sudden, every day I would say almost every day or every week, you wake up and you find out, hey, some legacy smart contract has been attacked exploited by some AI, latest models, Fable 5 or GPT 5.6 or Kimi K3, whatnot. So in the age of AI, especially in smart contract, it's very difficult to defend because it's immutable. Right? Once you deploy, it's immutable and it's open source. So you're like a static project and you are managing money. So that makes it like a honeypot for any kind of attacker. They can now use powerful AI models. And these models, they are just the cyber capabilities. They're growing like almost exponentially. To me, it's just a matter of time before any smart contract is going to be. I wouldn't put any money in any kind of smart contract today. I mean, legacy ones. So we need something in the age of AI, almost like a smart contract language for Bitcoin script, but that can help us defend against AI attackers. So Lambit is this the latest, realization of this, Bitcoin script potential, meaning it still gets compiled down to Bitcoin script, but it has a bunch of features that make it I wouldn't say completely resistant, but it's at least alleviate the attack surface. For example, is pure, meaning It's like a math function, right? It's if you in the program world, it's pure meaning. It's like you are almost like doing math. Okay, there's no you cannot mutate state. You cannot have side effect. Everything is like a math function, right? Function in math is very deterministic. For example, you can do square, right? Square of 3 is 9. Doesn't matter where you do it, how you do it, it's always coming up to be 9, exactly. So it's very easy to reason. And second of all, we will make, I mean, today is still early, but eventually, I think even in short term or medium term, we want to make it formally provable. Meaning, what does that mean? You can prove your program have some, let's say, properties. For example, you can say, hey, if this is using tokens, you can prove the output can never exceed the sum of inputs, right? So you can never have inflation. Or you can prove your Bitcoin locked in this smart contract can never leave or eventually can exit. You can prove all these properties. I think that's the most powerful way to defend against the AI models, because if you make it math, it's like you are proving some like theorem. Once if you can prove it, and then you are going to be super confident it can work. It doesn't matter how powerful the model is, because it's by proof, for example, induction. It's secure, not by some like syntax or cleverness in the programmer's hand. Those are very human, centric. It's very easy to be broken. So we want to make it, pure functional, also formally verifiable. And lastly, also has to be very friendly. So that's why it's also TypeScript. It's not a new language. It's the same philosophy with sCrypt, but it's pretty much like sCrypt, but for the AI era. Does this make sense?
Yeah, that makes sense. So it's, I mean, could you have, I guess, maybe rewritten sCrypt to continue with the sCrypt brand and also conform to those goals that you just mentioned? Could you have just used sCrypt or like upgraded sCrypt to a different version for that?
Yeah, I think that's my first thought when I first have the idea, but I would say it will be very confusing because it's going to be very, very different. And then the paradigm is shifting. In sCrypt, it's so-called the imperative language, right? Basically, the most obvious difference is you have variable and mutable variables. For example, you can have, a counter, you can have a, loop variable called I, and then you can increment it. You can never do this in Lambit. Actually, the Lambit is a play word called lambda. Basically, in the programming language world, when you say lambda, people immediately think about functional. It's another paradigm. So I don't want to confuse people, and it's also in the age of AI, is something like more AI ready and native. So that's why I decided to create a separate name. Meaning Lambit is called Lambda, meaning functional, super secure, and also Bitcoin, of course. So it's called Lambit. So that's why you have two different languages. I mean, share some philosophy, but on the surface, it's very, very different.
Okay, so we have sharing my screen right now, and we're looking at the Lambit Forge application right here, which is basically your web IDE for like a Lambit playground that anybody can come and kind of test around with Lambit. So the default sample contract it's giving here, it's a simple counter contract, right? Everyone's familiar with the counter contract, and so yeah, if you can, maybe walk us through the syntax here, and then we can kind of see how it compiles to the underlying opcodes.
Okay, sure. So, first one you notice is this is just TypeScript. Okay, so you can think of it as it's just a library. Okay, you can use npm to install it, and you can manage it. So as a contract, everything here is a function. Everything is a function. Literally everything is a function. That is functional. It's not imperative like for example, C or Solidity or JavaScript. So everything is a function. You call it and then you got a result. That's it. It's like a math function, right? You can square it. You can square root. You can do add. Everything is deterministic. So when you have the contract, this is like how you create a smart contract. Basically, if whatever goes into the script part of the UTXO, right? And you have a name, but then you also have some other properties. So, for example, you can have this state. In the third, I think the third one, the count basically is what you want to mutate. You want to keep track of, which is the state. Okay, so the state for contract in the UTXO Bitcoin world is very different from Ethereum world. Ethereum world, you have a global state. Basically, you have think about it, you have a huge map, global, you have only one map, and everything goes there. It's like super big database. And then on the Bitcoin world, in the Bitcoin world, you don't have such global state because basically that's where Ethereum can never scale. It's like you have a single variable, you have a global variable. Any programmer, on the first day, when you take a CS101, you always have a global variable. But then later on, when you get into more advanced topic, you know why it's never a good idea. You're pretty much, you have one thing, and everywhere you are trying to mutate the same variable. You can cause a race conditions, you can have re-entrance, you can all kind of problems. But okay, I'm diverging. Let's come back. So you have state. So in the Bitcoin world, everything is local and pure. Basically, there's no state. There's no state. So in a functional paradigm, for example, in Rust or so-called a bunch of other functional, it's all pure function. But in pure function, you can also create the state of a mutable. That mutable state is the way you always return the last state and then put it as an argument into the next call. So that's how you can have mutable state, even though every step is pure. You are not mutating. So for example, it's like you have a math function called increment. So how do you, every time you can only add, you have only one function. What does the function do? You have x and you put it x in and then give you x plus y. So that's pure, right? Which is like whatever we see here. For example, on line 9, right? You are not actually overriding. You are basically return what's the next state. I mean, you can see from the next field. Basically, you have a current count, so you can just add it. But you are not overriding the old one. You are just returning the new one. Does this make sense? So
yeah. So if I can, I guess just simply explain it. So the state, like you said before, it's carrying over to the next transaction in a way. So like the state would live in the script pub key or the output of a previous transaction. And then when you want to increment or do any kind of state changes to that state living in that previous transaction, you would make a new transaction. And during the unlocking of the locking script, during that process, you're actually creating the new state or taking the previous state, creating a new state, and then returning it into the next output. Is that kind of correct?
Yeah, exactly. So think about the simplest transaction. You have one input and one output, okay? And in the input, basically is the old state. And in the new UTXO, you have the new state, right? For example, in the counter example, you have the previous count, maybe let's call it X. And then what the contract is only enforcing that the next state will be exactly one bigger than the old state. That's everything. So in this sense, by design, Bitcoin smart contract is superior to Ethereum. Ethereum is so-called state machine, right? So you have an old state, and then you run some code, and it goes some new state. suppose, supposedly that's the state you want you want the contract to go next, right? But you never know, right? That's why you have all kinds of bugs. But on the Bitcoin world, it's not like you are mutate state. You are only verifying it. So you specify where it should go. And then you check, this old state and new state satisfy your spec. So that's why it fundamentally is just a better design. Does this make sense?
Yeah, I guess so. I mean,
you specify where it wants to go, and then you verify it does. And on the other side, it's like, hey, I think it goes there, but you never know.
Gotcha. I think also the fact that another reason why this is, what you would think as superior as global state in Ethereum is the fact that, okay, for every transaction, not only are you creating the new state, but you also need to specify where it goes next. And also you need to prove that you can make these next changes to the state. Is that fair to say?
Yes, because otherwise the unlock will fail. This transaction will just get rejected. And if you notice in Ethereum, even the smart contract fail, it will still get, embedded into the blockchain, which is kind of basically you get all kind of super weird and all this wise but very bug pro. And the last thing I want to emphasize, everything here is every information you needed when you check whether this is right or not is local. You don't have to go to fetch some other transaction. Or of course, the only exception is you're fetching the UTXO from the previous transaction, but you don't need to go to some other random places and check whether it's good. Or you have to trace up to a few previous transactions. You never have to do. Everything is local. So that means it's scalable. You don't need to go. It's like, everything is localized. So that's why it's scalable. I don't have to go to other places. That's not the case for Ethereum, because in the Ethereum world, every contract can call any other contract. You basically, you're all over the places. It's never going to be scale, and also it can never be made safe because anything can happen. So in the Bitcoin world, it's very elegant. You only have to, hey, you want to check this transaction is good, you just check, and maybe it's parents and whatever inside the transaction. That's it.
Yeah, it makes sense. So this is probably, I would say, the most simplest Lambit contract that one can create. And it's only basically with state.
Yes.
And it's basically only like 12 lines of code. And so what we're going to do now is we're going to click on compile, which will then let us see the underlying opcodes that it'll compile into. And those opcodes are the opcodes that would be basically embedded into the Bitcoin UTXO or the transaction. So I'll go up here and click on compile. So once you compile it, I mean, I would say there's about like 100 opcodes compiled and outputted. And then so I guess my question for you, for a developer, how would they go, if they wanted to, how would they go about, I guess, debugging those opcodes themselves? Or should they at all? Like, should they just trust the Lambit code?
No, they should only debug at the Lambit level.
Gotcha.
Basically, for example, if it fails, let's say you are debugging, you should only step over the source code of Lambit. You never touch. It's like EVM opcodes. You should only step through the solidity. You should never, assuming there's no bug in the compiler, which shouldn't happen. So you should only check your logic, your business logic in the source code, not at the target code.
Gotcha.
So I want to emphasize again, I think for any developer out there, please don't work with sCrypt. It's 2026. You should never touch, Bitcoin sCrypt. I think a lot of people, that's just my assumption. I think they're trying to show they're very hacky, or they're very, sophisticated. So that's why they, still play with opcodes. So but it's like playing with, EVM opcodes when you already have solidity. It's not a good look.
What would you say were the hardest parts of building a compiler targeting Bitcoin sCrypt?
Yeah, that's a great question. Because when I first started out writing the compiler, I was that's not much, because if you take any kind of computer science, program, as part of the course, you need to build a compiler. So suppose everybody can build a compiler for some kind of like a small language, but for Bitcoin's script is very unique in the design, which make it more difficult. One, there's no memory, there's no storage, there's only stack. It's very unique. For all the other virtual machines I know, you have storage, like a memory, right? You can store it and then you can load it later. Basically, you write it and then you can read it later. In Bitcoin world, it's not. That's only stack. Okay, and it has two stacks called dual stack. The main stack, the auto stack, or called the control stack. Okay. Number two, you don't have so-called call function call primitive. Like usually you have some kind of like you can define routine and then you can call it with some kind of like a jump. There's no jump instruction. So it's very difficult to implement function call. But also it's for good reason. It doesn't have jump, because if you can jump, you can never know whether you will stop. In the Bitcoin world, it's a nightmare. You have everything so-called has to be, in computer science terminology, it has to be decidable. It's going to halt. So that's why you have to, minimize the number of what kind of instruction sets opcodes you can have. So it doesn't have jump. So you have to figure out how to do function call. Basically, you inline the code. So whatever code you're going to call, you just copy all the whole function body there, copy paste. So that's how you have to inline everything. Three, I think one of the biggest complaints, there's no loop. Okay, right? Because also there's no jump. So not only you cannot easily do function call, but also it's not easy to do loops, especially unbounded loops. But also unbounded loops, you can never have that in Bitcoin world, right? Imagine you write a program, it's like you loop forever. It's never the Bitcoin just stopped. It never want to have that happen for good reason. So all of this is very different from any other virtual machine I know of. So you have to come with new ways. For example, if you do loops, even at the CPU level, right? How do you do loops? If you loop 5 times, you basically run the same code 5 times, right? So for us, every loop has to be unrolled, for example, unfolded at compile time. Basically, if you want to run this piece of code 5 times, you just copy paste 5 times. You expand it at compile time. So that's also very unique. And you should never have unbounded loops. You can never say, hey, if this condition is true, keep iterating. Never do this in Bitcoin because it may never stop, right? So but all this can be overcome. Basically, eventually we find out ways, and then we make me appreciate more about the design, because it may looks very cumbersome at the beginning, but then eventually when all this to make sure the script always terminates. Because if as any script does not terminate, is a disaster for the Bitcoin. Basically, it just keeps looping. And it's not a server. You can just restart, right? Because it's a global consensus network. If one gets stuck in a forever loop, everybody is stuck in a forever loop, and every transaction gets stuck. And I don't think it's easy to restart. So it's all good design, but then we just to get around so-called, I wouldn't say limitations. It's just a uniqueness. We have to, get around it, and eventually we fix all those issues, and it works very good. Yeah.
Gotcha. And then, if developers were to look at the compiled opcodes from their Lambit contracts, they'll instantly notice that, opcat's going to be in there, and some of the other disabled opcodes in there as well. And that's honestly been like the mantra and mission for yourself, just promoting this whole re-enabling of these old opcodes, especially opcat, hence the reason why opcat layer is named after opcat.
Exactly.
In your opinion, what do you think is the current state of this restoration of all these different opcodes, right? People are calling this the Great Script Restoration.
Yes, I think it's in a lot of developers' mind, and some people will just keep constantly talking about it. I think that's another one of Bitcoin Plus Plus that was just in Berlin, and I'm going to talk about on stage in Hong Kong I think next week. So Bitcoin Asia, I don't know whether you are coming, but yeah, you should join. And people always bring up the idea, because for those of us who have been in this space long enough, we just find out, Bitcoin is it's like iPhone, okay? And then later on, you just removed, I don't know, the camera or the GPS component. Disabled. I would have, it's disabled, right?
Yeah.
It's kind of weird because it's supposed to be smartphone and people only make calls, maybe send some text message. That's how I feel. The iPhone moment, why has not arrived yet and all the killer use cases? Because for historical reasons, people just disabled, or crippled these functionalities. And I just want to make, for example, some kind of, not exactly that, but I'm making like Android with all these fancy capabilities. So, hey, you can build games, you can do banking, online banking, you can play games, fast, cheap, everything. And then hopefully the iPhone people will say, hey, maybe Steve Jobs was right. We should, get the cameras back, get the GPS back, get the accelerator back. And then you can make, I hate to use the word, but make Bitcoin great again because it was great, but then it was crippled artificially. And then if we can show, hey, you can do all this fancy stuff. You don't need other blockchains basically. It is the first design was still, in my opinion, is still the optimal in terms of scalability, programmability, and all the economics. So you still, Satoshi already solved all those problems, but for historical reasons, people have not fully realized what's its potentials. So that's why we want to demonstrate and then get people all back to the mother chain. And then I think that's have a bigger shot than just we work on, 10,000 blockchains. We all fragmented.
Yeah, that's a good analogy, honestly, of like an iPhone, Steve Jobs deciding to disable the camera and the microphone.
Yeah, he may find some defects in one version of the camera. That doesn't mean he's never going to bring it back. He was like, hey, maybe there's some defect. Let's fix it and then bring it back, right? But then imagine he just left and then people just forget about it. So that's the advantage. Yeah.
And that's honestly the whole purpose of the opcat layer is to demonstrate, okay, well, this is what you can do with all of these different disabled opcodes. Okay, cool. And then so to wrap it up, for developers that are new to Bitcoin and that want to work with Bitcoin sCrypt, it would be safe to say that, oh, well, we can encourage them to try out using Lambit. Is that correct?
Yes, or sCrypt. Yeah.
Yep, sCrypt or Lambit. Would you say, there might be some critics that might say, well, using these higher abstraction languages might, I guess you can say, remove or alleviate or, I guess, prevent the developer from learning more specifically what's happening within the transaction execution. What would you say to those people that give you that kind of argument?
Okay, the whole history of computer science is moving up the abstraction layer, right? For example, when we first start program, you program 0 and 1s, right? And then you program assembly. And then you program, C, and then you may have programming some even higher level abstraction with. And then today, people don't even know how to write program. They can just ask AI to vibe code, right? So if you look at history, the evolution of the whole programming space is doing. You have to, abstract away from the 0s and 1s. So you should never go back, and unless you are like working with the, lower level yourself, like compiler or optimization or whatnot, right? Or you are working with LLMs yourself. But other than those, like a few niche, developers, most developers, regular developers, they should come up with only the latest tools, make it simpler and easier for anybody to program, right? It's almost like you are democratizing the programming, right? Because, back in the 0 1s, maybe like a handful of people can program. But now today, I think anybody who's interested in, AI coding agent, they can just vibe code a website or game or whatnot. So in that sense, you don't want to go back. You should, just make it easier and easier unless, you are doing the lower level stuff. So that's my counter argument for those people. In today's age, you should never. It's like, it's almost like you're going back in the community. Today we have internet, we have, teleconferencing, you are like going to, I don't know, pigeons or sending mail. It's, we're here we want to move to the future, not going back to the past.
Yeah. It is interesting. That's a good argument. That's a fair point. But it is interesting how, like, when we see incidents like the Coldcard incident happening,
that's another big reason why you should have opcat. So you can have vault, you can have checking balances, you can have spending limits, all enforced at Bitcoin sCrypt level. So anyway, sorry for interrupting. Keep going.
Yeah. Oh, no, I was just saying how like there's like abstraction that's inevitable and that's going to be happening as technology advances. But then I recently saw some proponents that because of the Coldcard incident, some proponents are supporting the whole manual entropy kind of process again, right? Being able to roll your own dice and create your own, 256 bits and whatnot. What would you say to those people that are kind of encouraging that?
I mean, it's always going to be niche, and it doesn't matter if you roll your own dice. If the code in the firmware has bugs, it doesn't matter whether you are rolling your own dice or not, right?
That's
so you want to make more programmable. I think that's a big that's I think the biggest incident I would say that's bugs for Bitcoin upgrade, because we are always talk about spam 110 and a bunch. I just find all this distraction, because we are not working on, it's like we are working on some apps that consumers use, our users. They're always complaining, or they have huge vulnerabilities. They may lose a coin, it's very expensive, very slow. And then we are working on something like we're changing the color of some menu or button, which they don't care, and they shouldn't. It's, to me, it's like we're talking about spam or debating. It's like we're not working on the right problem. I think this incident hopefully is a wake-up call to the community. And this is a real problem. The real users of Bitcoin, they're self-custodial, they are rolling the dice, but they got hacked, which should never happen in the first place. So let's focus on the real problem people face, or it's expensive, or it's slow, or the security budget. I think that's why we have opcat layer. Basically, we want to tackle all this problem. Security budget, where if we have a lot of transactions that are doing merge mining, so they can the miners, they can get a lot of fees almost for free using the same ASICs. And we have opcat. So basically, if you have time, or I'm going to create this vault smart contract, basically, which can make sure the Coldcard hack can never happen again. Even if it happens, you can detect it, and then you can reverse it. So I think that's where showing the real benefits of why we care about sCrypt, because it's not there for, just to show it's cool. It can really solve real problems.
Gotcha. Yeah, maybe we can dive more into that later at another time.
Yeah.
But
yeah, for sure.
But yeah, so thanks again for Bruce for coming on this episode of Peeling Bitcoin. It's been a pleasure kind of tinkering your brain about sCrypt and Lambit, and what made you discover Bitcoin script, and what made you want to make writing script a lot easier, and the benefits around that as well. So thanks again. And for anyone that's interested in learning more about Bruce, check out some of the description and links below. And of course, you'll be able to link through to different resources on learning sCrypt, Lambit, and also the opcat layer. So yeah, thank you again, Bruce.
Okay, thank you again for the invite, and catch you later. Thank you. Have a good one.